Welcome back to OK Calculus. This time we're doing a live recording of me doing some example problems for you. I'm going to go over some of the rules we've talked about, like the power rule, the product rule, quotient rule, and the chain rule, as well as tying into other things I said in previous videos. This is going to be sort of a review slash practice problems we can go over to ensure that you know these rules. So the first problem I'm going to do is f of x equals x to the fourth plus 1. See that there? So for this problem, would obviously deal with the product rule. So as we learned the product rule, you take the exponent, which is the 4, and you bring it out front, and then you drop this exponent right here by 1, bringing that down to 3, and obviously you move the 4 right there. So let me just rewrite this, it looks a little cleaner. So f of x would then equal 4x cubed, and then the 1, as I mentioned earlier, you kind of treat this like it's multiplied times x to the 0 power, because anything to the 0 power is 1. So then if you were to do that, you could imagine it going up to the front. 1 times 0 is 0, so the whole thing would just be 0. So that is non-existent right there, and that would be your answer right there. And now for the next problem, we're going to do something that involves the product rule. And so let me write the problem here. We're going to be finding the derivative of this function. F of x equals quantity x plus 1 times the quantity x squared plus 2x, parenthesis there. And so we're using the product rule, and if you remember, the product rule is first d second plus second d first. So what that means is you're taking the first quantity times the derivative of the second quantity plus the derivative of the second quantity, or derivative of the first quantity times the second quantity. So let's just do that. So it makes a little sense here. So first equal sign, first quantity, the derivative of the second quantity, and we're kind of mixing two rules here because you're using the power rule, bringing that 2 in front, and then treating this as if it's a 1 in the exponent. So you're taking that out front, dropping that to a 0, so you're just getting a 2. So you got 2x plus 2, and then adding second d first. So second quantity, just writing that down, d first. And d first, that, like I said before, all constants, the derivatives are 0. So we got 1 and plus 0, so just 1. So that ends up not really mattering because it's just a 1. And you could simplify this down, which I'm not really going to. You can just FOIL this right there and add it. Takes a little while, but you can get the gist of it there. And so on to the next problem. Alright, the next problem here is going to be dealing with the quotient rule. And if you remember from my previous video, quotient rule, we'll be going over that right now so you can get the gist of it. So let's write down the problem here. We're going to be finding the derivative of this equation. X squared plus 2 all divided by x to the fourth. And as I was saying, there's another saying for this one, which is low d high minus high d low. Draw a line square below. And like I explained in the video, taking the low quantity, d high, derivative of the high quantity, minus the high quantity, minus the derivative of the low quantity, and then you're taking that and then squaring it. So let's do this here. So low quantity, x to the fourth, put the parentheses there, d high, once again using power rule, 2 to the front, dropping it by 1, so you get 2x, and then all constants, derivatives are 0, so 0, and I'm going to write that, minus, not a plus this time, it's a minus, high, so you just take the high quantity, derivative of the low quantity, taking that 4 out front and dropping the 4 by 1 to get a 3. So you're going to go 4x cubed. And then the key step, the last key step, was step 4 in my previous video. Taking all that divided by x to the fourth squared. and that ends up being x to the 8th. And once again, you can FOIL this out and multiply these, and then this obviously gets you x to the 8th, but I'm not going to because I just want to go over the derivative rules and not foiling rules. On to the next problem. And now into the next problem. This was the trickier rule from my previous video, which is the chain rule. Went over it briefly, and like I said, I would go over it in this video to make sure you understand what that is. So let me just write down the problem we're going to be doing as an example here. F of x equals x plus 1 squared. Now to find the derivative of this, I'm going to be using chain rule like I said. It basically is kind of like the power rule, except for it's a little more complex. So basically what you're going to be doing is you're going to be taking this 2, putting it out front, kind of like the power rule, and once again dropping that by 1, so it gives you 1 in the exponent. So it's going to end up equaling 2 and then x plus 1. Like I said, it's like unpacking boxes, where you got to do the first step. You got to unpack the first box before you can get to the second box. So this is the first box, you're unpacking it here, so you got that, but you want to retain that. Plus, then you got to take the derivative of this right here as well, which doesn't really matter because the derivative of x plus 1 is just 1, so it really doesn't matter. But if it was an x squared, you would have to put a 2x right there, and then multiply it with the 2 to simplify it. But yeah, that's just an example of the chain rule. Hope you understand a little bit better. So let's go on to the next problems I have for you here. Okay, so for this one, just to check your understanding, I'm just going to write a problem down. I'm not even going to do it. I'm just going to ask and see ask you and see what rule you think we should use for this problem. Alright, so the first problem I'm going to write down here, we got f of x equals x cubed plus 2x minus 1 divided by, that should be a hint by the way, x plus 1. See that there. And then obviously you might have probably already figured it out by the division sign. It's the quotient rule. So it'd be taking low d high minus high d low, draw a line square below. I'm not going to do that, but so yeah, this one would be the quotient rule. Just write that down there. That is the quotient rule. And then let me write down another example problem here. F of x equals square root of x plus 2. This one's a little bit trickier, not as dead of a giveaway as the first one. So if you haven't guessed it, it's actually the chain rule, believe it or not. And why I say that is because you can treat it as if it equals x plus 2 to the 1/2. And if you saw that, obviously you'd say chain rule, because it's just like if there was a 2 in the exponent, you'd bring that 1/2 up front, and then you actually have to drop the 1/2 by 1, so you get 1/2 x plus 2 to the negative 1/2, and then obviously you have to multiply it by the derivative of this right here, which is just 1. But yeah, that one's a little bit trickier, not as easy to spot, but whenever you see a root or something like that, turn it into a number in the exponent, and it'll probably make it a little easier for you. So this one was the chain rule. Alright, and then for the next one, this one will be f of x equals pi squared. Now I know you might be thinking that's chain rule, or I'm sorry, product rule, but that is actually not product rule, believe it or not, because as you know, pi is not a variable. Pi is actually a number, which is roughly 3.14, and 3.14 squared, I'm not sure what that is, but it ends up being just a number. And like I said, the derivative of any number that's just a constant without any variables is always 0. It's always 0. F prime of x equals 0. So yeah, a little bit tricky. Don't fall for it, because pi is a number, not a variable. And like I said, constant derivatives are always 0. And then for the last one here, we got f of x equals x squared plus 2x plus 3. Now this one's pretty easy. It's just the power rule, except you got to do it on multiple things. So you got the 2, bring it out front. You got the 1, bring it out front. And then you got the 3, which is obviously 0. Not going to finish the problem, but yeah, that one's just power rule. Alright, I'm not sure how you did, but like I said, just don't fall for that kind of stuff. Rewrite that to make it simpler. Look for division lines. So yeah, on to the next part. Alright, for this next part I'm going to explain the kind of last thing I talked about in the previous video, which was the derivative of sine or trig functions like sine, cosine, tangent. So I just want to review that real quick. So you got f of x equals sine x. You might see something like this. And like I said, I had that chart in my video, which was SC negative S negative C. And like I said in the chart, you go down the line and those are your derivatives. So the derivative of sine is cosine, and the derivative of cosine is negative sine, and then the derivative of negative sine is negative cosine. And like I said, it's an infinite loop because this goes all the way back to sine. And so it's just an infinite loop. So let's kind of mix that concept and mix it up a little bit here. So we got the function f of x equals sine x plus 2x. Put the parentheses there. This is kind of mixing two worlds here. You got the trig functions plus the just the regular function that we've been practicing. So we know from this chart, so we got sine there, so you just go down, cosine. That's so f prime of x equals cosine x, and then power rule would tell us treat this as a 1, bring it out front, and then drop it to a 0. Be just 2, and that would be your answer. Now let's combine those skills with the product rule. So we got f of x equals sine x in parentheses 3x. Alright, this basically kind of, you obviously see that we're going to be using product rule for this one. So you go, it's just the same as any other thing you do. F prime of x equals first quantity, d second, which is 3, plus second quantity, d first, and d first, obviously like that chart I had, it's just cosine x. And of course you can clean that up by foiling, but like I said, I'm not going to be doing that because I just want you to get the general rule. Now it's this final thing I want to do is mix this with chain rule. This is where it gets a little weird. So we got f of x equals sine of 2x. Sine of 2x. It's in the parentheses, it's not outside, it's in the parentheses. So how would you do that? Well, you just kind of treat it like how you would x plus 1 squared. You'd bring the 2, drop the 1, and then take the derivative of the inside there, kind of the guts, and you get the 1. Do the same thing, except for there's not an exponent. It's the sign that's kind of the outer shell, the box. So you gotta take the derivative of the box first, so f prime of x equals, so you gotta take the derivative of cosine of 2x. You gotta retain the inside, and then once you've unpacked the first box, then you can go into the next layer, which is the 2x. So, and then you gotta multiply by the derivative by that, so it's times 2, because the derivative of 2x is 2. And so if you just wanted to clean that up, it'd be 2 cosine 2x. Simple as that. Alright, and then that's basically all the example problems I have for you. Just kind of wrapping up all the rules of derivatives. Hope you gained more of an understanding on how this concept works. Thanks for watching.